I'll start from a very basic, stating that about binary numbers. Okay, so binary is made of 0 and 1. Now when you say 0, 0 is an off state, 1 is an on state. On state means where you have 5 volt or more, and here it is 0 volt. So this is how is your connections. So let's look at certain circuits. Now before we go to and or, I'll just talk about a buffer. So a buffer also is similar to the not, except a little change in there. So what the buffer has is, okay, so buffer, if its input is A, the output is also is A, there is no change because its in and out is the same thing. So if the input is on, okay, so output is also be on. If the input is off, then it will always be a 0. So it gives you the same thing. So there is no change in the buffer state. Okay, so that is buffer. Let's go ahead and see for other circuits. So after buffer, what we look at is NOT gate. Okay, so the difference between NOT gate from buffer is you have a small circle at here. So how does NOT function? NOT will always give the, if input is A, so the output will be A's complement, or you can even write, okay, so it's the same thing. So if you are taking the truth table for A and out, okay, so if it's an off state, the output will be on. If it's an on state, the output will be off. Okay, so it's always the reverse of what your input is in the NOT state, because we talk about the reverse order. Let's look at AND gate. So let's look at the truth table. If your input is off state, the output will be also off state. If A is on but B is off, still it will give you an off state. If A is off and B is on, still it will give you an off, because we are talking about AND. So here if A is on and B is on, that is 1 1, then you have 1. So that is your AND gate. Let's look at the opposite of AND. Not exactly, but just for the purpose of saying, let's say OR. Now how does the OR gate work? There's little change in the diagram of OR. A B gives A plus B. Okay, A plus B is here A or B. Okay, not an addition. It is the symbol which you use in Boolean algebra to represent OR. So let's look at how does the truth table of OR will work. Okay, now when we say OR, it is either of them, right? So A, B, and the output. Okay, so if A is off, B is off, obviously it will be off. If A is on and B is off, still it will be an on state, because 1 or 0 is still 1. If A is off and B is on, it will still be on. If A is on and B is on, it will still be on. Okay, now let's look at a comparison between AND gate and NAND gate. What is the difference between AND NAND? Okay, how does both of them work? Okay, so let's look at AND and not a NAND. Okay, so AB NAND. So NAND will give you AB complement. Okay, now one thing you have to remember is if 0's complement is 1 and 1's complement is 0, so it works on the opposite way. Okay, so just remember these small kind of things. Let's draw a truth table. So let's first populate this. Now, as you have seen this, I don't have to repeat this. Now, well, let's look at NAND gate. It is 0 0. Let's populate 1 0 0 1 1 1. So here, if both input A and B are on, the output will be the reverse of it, so it will be an off state. And when this is off state, everything else will become an on state. Okay. Now, if you see both AND and NAND, I'll change the color and show. Now, if you look at this column and this column, don't you realize that this is both the complement of each other? So what you see here in this and what you see here are opposite of both the things, right? So let's see something more. Okay, now let's draw one circuit and see how it works. Now, what will input A and B will give in the AND gate is AB. So the input of AB with a NOT gate will give you AB complement, right? So let's see if I don't you think it can be resembled as NAND gate if I do the same thing? So I, instead of that, I draw it's the same thing. So I hope you're understanding this, Pratik. Now if I do this and I connect these two, okay, what kind of gate is this? Okay, let's draw it to show you. Okay, so let's draw something to explain. AB gives you complement, right? What you have seen before with the NAND gate. So now if you take this A and A, now you multiply A into this with this, what you get is AA is complement, correct? So if I say what is A is equal to what? So there are the rules which you always have to remember, which we have done previously also. So just remember those rules. So if A into A is A, or it is 0 into 0, you get A. 1 to 1 is equal to 1. So these rules you have to remember, these things. So remember these rules always, right? So now what is the answer for this? This is similar to A's complement, because what you see here is the same thing. So these are the small rules which you have to remember. So now the same thing I can do is create a NOT gate, right? So A, so these two becomes same. So let's draw a truth table for the same thing. So let's change the color. A, B, AB complement gives 0, 0 will give you 1, and 1, 0 gives 1, 0, 1 gives you 1, and 1, 1 will give you 0. We have seen this before. So let's draw the same thing with the this, okay. So A, so if you see that if you're working, these things cannot be used, these things cannot be used in here, because when you look at here, okay, or we look at this position, right? Now if this is 0, this has to be 0, this can't be different, right? So if this is 1, this has to be 1. It can't be that this is 0 or this is 1, it will not work. Okay, so if you're connected in this situation. Okay, so let's okay, so I'll just write it. If this is 1, this will be 1, this will be 1. So the 1's complement, you'll get it. Sorry. So this becomes 0. Okay, so if I say 0, 0 will give 1, 1, 1 will give me 0. Let's look the same thing using OR and NOR.